Welcome back, everybody. This is the second video where we're going to talk about Chapter 4 in this book here, the AP Computer Science Exam Prep book. So today, this is a fairly short chapter. We're going to talk about using classes and objects. Objects and classes in computer science are very different. They're not the same thing. I'm going to kind of gloss over that in a later video. We're actually going to talk about how to write a class, and then it'll become very important what the difference between an object is and what a class is. I'm going to kind of ignore that for this lesson here. In fact, I'll just call them classes. They are classes. We're going to talk about how to use classes, particularly two. Your programming language library that comes with Java or any other major language is quite extensive. It's got lots of libraries in there to help you do all kinds of different things. So what is a class? Think of it this way: it's a collection of useful things that go together. Okay, so for example, the two classes we're going to talk today about are the string class and the math class. So the math class is shockingly full of lots of useful things that deal with math. String class full of string related things. Again, don't worry if this is a little fuzzy. We're going to get into a lot of detail when we talk about how to write your own class. But today I just want to show you how to use a class, particularly a library class like math. The structure is very simple. You start with the name of the class, and again, this would be given to you by the library, whoever wrote it, in this case Java. So Java has a math class, math, and then there's a dot, and then the name of some method. What's a method? Well, let me write it down and I'll explain what it is. ABS. ABS is short for absolute value. What is this? This is called a method. Method is very much like a function. There is a difference, but I'm not gonna get into that here. You've done functions in math before, right? You put something into it, the function does work, it produces some value out. Basically, method is the same way. In these parentheses are the arguments to the method. There could be one, there could be several that are separated by commas, or there could be none. You could have something like, foo with nothing. That method requires none. How do you know what's required? Well, usually there's documentation. Actually, not usually, there is documentation. So somewhere in the documentation of this math, it'll say something like public, I don't know if it's int or double. Is it an int or double? Yeah, it's an int. Int ABS, int value, something like this. And we're going to look at this all again when we write our own classes, but just for the purposes of documentation. This is going to tell you the value that's returned. When the work is done, it's going to give you some value back, in this case an int. This is the name of the method, ABS for absolute value. And then this here is defining one argument of type int. So in other words, you pass in some int, and it gives you an int back. That's the absolute value. If there were more values that were required, then there would be a comma and some more stuff here. Now, why is this important? Because this tells you what it needs. If you tried to call math.abs and don't pass it anything, the compiler will blow up and say, hey, you're screwed up, you passed something. Or if you pass two things in, it wouldn't be happy with that either. It's expecting one integer in. If you pass a string in there, it won't like it. Okay? So let's look at a few of these. So I could literally say in my programs, math.abs -5. I can assign it to a value, int, x, and that x would be assigned. There's a comment, right? There's a good example of an inline comment. X is going to be assigned a +5 because it's taking the absolute value. That's fairly simple. So the point I want you to take home here is using this dot with the name of the class on this side of the dot is the name of the method that you care about, and then whatever arguments are required. So there's a few that are called out here in the study guide. If you look at if you have documentation, you Google it for the Java math library. You know, make sure you're sitting down. I mean, there's lots of stuff in there. Don't be intimidated. There's, you know, it's all good stuff, and you're welcome to use it all. But we're only going to look at, I think, let's see, 1, 2, 3, 4, 5 from the math library for our purposes here. So let's start with, we did the absolute value. There's actually a second absolute value, but I'm going to come back to it. Okay. Math.pow. That's short for power. Base exponent. Okay. So what you do here, it's kind of like, you know, you have x to the y power, where this is actually base to the exp power, and this is going to return a double. Okay. Now here again, if you looked it up in the documentation, it's going to specify all the details for two arguments. And actually, I'm curious. I don't know offhand if it expects integers or doubles here, but it returns a double. Try it. If the compiler blows up, that's not what it was. Okay. Third one. Square root. Okay, that's also going to return a double. And we have this one. This one's fun. Math.random. It's going to create a random number between 0 and 1. It's a double. So it'd be like, you know, 0.319, some big number, 0.1298, you know, just whatever, some decimal number. And it will never be above 1. It'll be between 0 and 1. It'll never be 1. I think it goes up to 0.999, whatever. And so that is a random number generator. And that's kind of fun because let's say you wanted to generate a number between 1 and 100. You'd say something like, let's see, double num, the math, random times 100. So that would be basically a number between 0 and 99. Now that would actually be 99 point something. That'd be a decimal point. So if you wanted to get rid of the decimal point, you could cast it to an int, right? You could do that. There's actually better ways to convert that to an int, but you could do this. That works. Okay. All right, so these are the 4 basic library functions we're going to talk about. I think there's a constant that they have in here too. They do, yeah. Math.py, Pi. 3 guesses as to what that is. Now this is not a method. You don't pass anything in, even an empty method. It's just a constant. It's a value because it doesn't change. But this way you don't have to keep repeating yourself. You know, it's like pi is a very common known number, so there it is. Okay, that's a double, of course. All right, now here's something strange. I'm going to throw this out here. Math.absy. Okay, so what's the difference other than the fact I chose x and y differently here? I'll use a different color. I know it's exciting, multiple colors. This one's an int. Okay. In this case, there are actually, this one accepts an integer, this one accepted a double. How is that possible? I kind of showed you how you define these methods, and you have to give the data type. There's no such thing as in Java of saying, well, take an int or double, right? You have to choose one. So how does this work? Well, this is a concept called overloading. This is where I have, somebody, I didn't write it, but somebody who wrote Java wrote multiple copies of the same method, but using different types. So one of them specified the argument as an int, the other had the exact same name, but the argument was a double. And if there were other numerical types, you could have other flavors of that as well. And that is just for convenience, right? So that you could take the absolute value of a double or an int. You don't have to worry about different flavors of it. Just say, yeah, I just want math.abs. And the person who absorbed the complexity of that was the poor guy who wrote the library, not you. You just get to use it and enjoy the convenience. But that concept of having multiple versions of the same named method is called overloading. And that's how that works. Okay, so that's about all we're going to do with the math library in Java. Again, if you want to look at the documentation, you'll see there's a lot of stuff in there. Pretty cool, especially if you're into scientific sorts of things or you do a lot of math work. Okay, so the second and I think final thing we're going to do in this chapter is a similar treatment with the string library. And string has, I think, even more stuff than the math, all kinds of cool stuff, but common manipulations of strings. But we're only going to look at a few common things here today. So what does the book want us to tell? Length, okay. We got length. So okay, for an example here. All right, so let's say I say string name is equal to Mike. Okay? Now there are some of these things that's a string class. So how do we get the methods out of class? We use the dot, right? So I can say something like name dot length. That's one of the methods we want to talk about. And that, of course, returns the length of the string. This is a variable of type string, so the length is 4. Not too surprising. Okay. I can say, let's change this up a little bit. Instead of Mike, let's say Mike space Smith. Now I can say string last name is equal to name dot substring 0, 1, 2, 3, 4, 5, 5. Okay, so what's going on here? Actually, no, I can get that's wrong. Let's say I just want the first. Never mind. Last, I want the first. Let's see if I get this right. 0 to 1, 2, 3. I think that's right. I'm trying to just section off the first name. So a substring is going to take a chunk of a name. And according to the documentation here, you need 2 arguments, the beginning index, each space is an index, and the end index. So it's up to but not including. So I think this is right. So here we've got 0, 1, 2, 3, 4. So substring starts at the beginning index, 0, and goes up to but not including the last one, 4. So this would actually return a string with just Mike in it. And I assign that to the first name. So if you have information, for example, that is highly formatted, like there's a number of characters for some field, a space, and some other characters in the page. You actually know the formatting of that string. You can use something like substring to grab a slice of that string and use it. It can be very handy. Okay. Equals. There is an equals on string, where if I say string x is equal to x, and string, say x2 is also equal to x, and then if I just had an expression here that says x dot equals x2, this actually returns true. You're saying, well, yeah, of course, these have the same value. So the question, though, and I don't want to go off to do too much of a dog trail, you say, well, how come this doesn't work? We'll see this a little later when we talk about writing if statements and stuff, but this is a way we sometimes test equality between two values in a lot of other contexts. It's like, well, why doesn't this work here? And it doesn't. Well, the trick is when you're talking about Java, to compare the difference of two values versus the values of the actual chunks of memory. So in this case, this is false. And why is this true? Because x here is a chunk of memory. Let's call this 1, 2, 3, just for fun. This is 4, 5, 6. This is x. This is x2. And they both have this value x in it. Okay? And these numbers just represent a slot in memory. They don't mean anything. But I put them in there to show that they're different, right? They're different actual boxes in different places in memory. X equals x2 basically is saying, are these the same box? They're not. They're totally different boxes, right? Equals here, x dot equals, is actually comparing the value. So is the value inside of x equal to the value inside of x2? Yes, it is. Now what if we wanted to make this true? We'd say something like x2 is equal to x. And so now x2 is actually pointing at this chunk of memory. This won't exist anymore. And so the value, of course, is the same and the chunk of memory is the same. If this is confusing, don't worry. That's not part of this chapter. I just want to explain it to you why these two things are different. For the point of the chapter, we're looking at this dot equals as a method in string. All right, I think there's one or two more. All right, what else do we got here? We got equals, oh, just one more, compare to. Oh, interesting. Okay. We'll try x again. Remember our earlier video I said don't name your letter, here's your variable, something short and simple, give them descriptive names. Now I'm just using x. Yeah. Okay. A, B, C. And let's say string y is equal to ABC. Okay, so they have the same content here, right? ABC and ABC. So if I say x dot compare to, get the spelling right, compare to y, what compare to does is return a value to let you know how these two things compare. So if it's the same, like it is, this will return a 0 because these have the same value. Okay? Now if I make this XYZ, That's not going to return 0 anymore. Now, let's see if I get this right. I think this is going to return like a -1. It's going to return a negative number. It may not be -1. Let's say less than 0. That's correct. It's going to return less than 0 because this comes before this alphabetically. Lexically, actually, not alphabetically, but for our purposes here. This comes before this. So it'll return negative. Now what if I swap these around? This is XYZ, and this is ABC. What do you think this is going to be? This is going to be greater than. It's going to be some positive number. So it can either be a negative number, equals, or a positive number. Say, well, okay, that's lovely. What good is that? Well, today, it's not of any good at all. But later, when we get to the chapter on where we talk about sorting, it's critical. If you're going to sort something, maybe you have a list of names, you're going to put it in alphabetical order, you have to be able to compare the things to know, is this one come before that one? And so this compare to method allows you to do that. Okay, I think we are about there. Yeah. Let's see, there's a concept here, mutable, immutable. Okay, so string is an immutable class. This is, I guess, a little bit of a detail. Immutable means you can't change something. Mutable means you can. So like if I say, down here, x is equal to food. Okay, x, the variable, is mutable, right? This is a detail, but I actually cannot change this string xyz. If I create a new string, like let's say I say x is equal to x plus hay. So then the resulting string should be xyz plus hay in one string. It would be, but technically I didn't change this string. This gets thrown away and a new string is created, xyz hay. The string itself is immutable once you set it. You can't change it. What you're doing here, even though it kind of looks like it's mutable, what it's really doing is throwing away the old one and creating a new one. Okay, and that is it. We'll see you next time.